Do you eat healthy or try to eat healthy? Do you think about organic versus non-organic food? Food is something you think about at least 3 times a day, and hopefully you think about it from the nutrition perspective.
Every day you are presented with so many food choices. For each food item, how are you supposed to pick the best product? With constantly changing dietary suggestions and diet plans in the media, it is no wonder the general consumer is frustrated and confused by the overwhelming choices they have at the supermarket. Have you ever wondered how healthy the food from the store is? How about the food you get here at a farmer's market, directly from the farmer's field? In this chapter, we will not only answer those questions, but we will also help you be more educated about reading the wealth of information contained on food labels. Bon appetit and enjoy learning about how the chemistry behind the food you eat influences your health.
This chapter and this week's discussion go into nutrition and the nutritiousness of food. So we'll talk about the components of the food you eat, how this affects your health. We'll look at every part of a nutrition facts label so you can understand more than just the calorie count, and even how the calorie count is determined. And we'll also get into food and environmental issues as far as sustainability. If you've heard of the term, "you are what you eat," well, that's mostly true. The composition of the human body is mostly water, so it's 56% water. And then the next is 21% protein, followed by 15% fat. So what's in food are these components: water, protein, fat, and carbohydrates as well. So the human body is water, protein, and fat, but most of us eat foods that are higher in carbohydrate and fat. Looking at some of these foods, unless you're eating, the closest to the human body composition is sirloin steak, which should make some sense because it comes from a cow, which is also a mammal. Sirloin steak is about 57% water compared to the human's 56%, 15% fat, which is exactly equal to humans, and 0% carb, which humans are 2%. And then 28% protein, which is more protein than humans have the 21%. But unless you're eating sirloin steak every day, you are not what you eat. Most of us are eating a lot of these, which are carbs, like chocolate chip cookies. So this is carbs, 69%, fat, 23%. So you're more like a steak than chocolate chip cookies. And you're probably wetter and fatter than you thought you were. And you also contain more protein than milk. So even though milk is considered by many to be a good source of protein, which it is as far as a drink, 2% milk is mostly water, 89% water, and just 3% protein. And humans are 21% protein. So when thinking about your daily intake of food, why do you have to eat food? Why do you eat 3 times a day and maybe more? It's because of your metabolism. Your body signals hunger. And the reason is we need food as an energy source. What happens when you eat food? You're taking in food, which is chemical energy. And so this chemical energy is broken down, digested, and the energy is used to heat your body. Heating your body is the most important, but also powering muscles, sending nerve impulses, transporting materials, and the food also provides nutrients that your body needs. So the food you eat supplies nutrients that are essential for human metabolism in the form of carbohydrates, fats, proteins, and micronutrients in smaller amounts. So what you do is you use the energy from the food, you also use the nutrients from the food, it's then digested, and what you do is you produce waste. Now this waste, the products of human metabolism, are similar to the products of combustion reactions, which are carbon dioxide and water. The most important component of the food we eat is the energy we get from it. So that's chemical energy from the bonds that are broken in the metabolism of food. So we get chemical energy when bonds are broken, and this chemical energy is measured in units of calories. So we can measure energy in different units. We've looked at units of joules, and calories and joules can be converted. So 1 calorie is equal to 4.184 joules. That's a conversion factor. And we saw joules when we're talking about electromagnetic energy. But in terms of nutritional energy, it's usually represented in calories. And this is a calorie with a lower C calorie, which is a chemical calorie, a chemistry calorie that you would measure in a lab. But nutritional calories are uppercase C. So calorie with the uppercase C is how calories are represented in food. And that uppercase C calorie represents 1,000 chemistry calories, or kilo, the metric prefix, which is 10 to the third or 1,000. 1,000 chemistry calories is 1 nutritional calorie. So the chemical energy from food is converted to radiant energy that's used to heat your body, mechanical energy that's used to move your body, and also chemical energy that's used in other chemical reactions in metabolism.